Today's lesson is stem and leaf plots along with distribution shapes for stem and leaf plots. The objective for today, the students will be able to create stem and leaf plots using 2-digit numbers, 3-digit numbers, and numbers with decimals. A stem and leaf plot uses the digits of data values to organize the data set. Each data value is broken into a stem and a leaf. Many times the stem is a digit in the tens place. Many times the leaf is a digit in the ones place. To create a stem and leaf plot, draw a T-chart. The stem is a digit or digits on the left. The leaf is a digit or digits on the right. A stem and leaf plot shows how data are distributed. Don't forget to make a key. The key explains what the stems and leaves represent. Very, very important. Make sure you have a key. Steps to create a stem and leaf plot. Order the numbers from least to greatest. We can do that with our graphing calculator. I will include a video that will be posted on how to use that. Decide on what place value will be the stem and what place value will be the leaf. Draw a T-chart. Write each value in the T-chart and create a key. Create a stem and leaf plot using the data set shown. It is currently in order. Make sure before you do your stem and leaf plot that all the data values are in order. Here's a T-chart. We have our stems on the left and the leaves on the right. They are all 2-digit numbers, so our stems will be the tens place and the leaves will be the ones place. Our numbers vary from 15 to 44, so our stems will be 1 for the tens, 2 for the 20s, 3 for the 30s, and 4 for the 40s. Putting in the leaves, make sure they are in order, and each of the data values is represented. So on that top row, that represents the numbers 15, 16, and 18. When you are creating this by hand, make sure that the numbers are spaced appropriately so that the distribution shape is easy to see. They need to be the same size and spaced the same amount. Here is our key, and the key tells us how to read our chart. I got mine from right here, this value of 15. So we have a 1 and a line and a 5, and that equals 15. Here's another explanation with stems, tens place, leaves, ones place, and what each of those values represent. We are not going to put commas in between our leaves. We will be using spaces. Stem and leaf plots, 2-digit stems. This is for 3-digit numbers. So here's our data set, lengths in centimeters. I have it on a box off to the right. They are 3-digit numbers. They range, and they are in order again, from 110 to 142, which means if we break up our data so that 2 digits, the hundreds and tens place, is our stem, then our leaves will be the ones place. Make sure you have a key. And there is the distribution for it. Those leaves, the lines, the number of values on each row are a lot. So sometimes we do split them up into a 2-stem split. That's what this says. If the data set includes values in the hundreds, it will be necessary to use a stem that includes 2 digits. The hundreds place as well as the tens place is included in the stem. The leaf is the ones place of the data value. When there are not very many stems and each stem has several leaves, it may be useful to create a two-stem split. There would be 2 stems for the 110s and 2 stems for the 120s, and so on. Stem and leaf plot, 2 stems. When creating a 2-stem split, like the one that I did up above, there would be 2 stems for the 110s, 2 stems for the 120s, and so on. The leaves of 0 through 4 are on the first row, in order of course from lowest to highest. And the leaves of 5 through 9 are on the second row, once again, of course, in order. Stem and leaf plots, numbers including decimals. Here's an example of a stem and leaf plot. If the data set includes values with decimals, use the line that separates the stems and the leaves as where the decimal point goes. We have a diagram there. It has the title. There's our stem columns. They are 2-digit stems. They are the value before the decimal point. The line is where the decimal point would be, and then we have all of our leaves, of course, smallest to largest. And make sure you have a key, because the key tells us how to read that. Their key, 14 line 2 equals 14.2 seconds, not 142. That's why a key is very important, so you know how to read the values. These are race times in seconds, and there's the data that comes from that stem and leaf plot. Here's another one where our data set includes decimals, and we can tell that by our key. 1 line 7 means 1.7. So we can get the data set values by reading the stem and leaf plot. We'll have 0.5, 0.7, 1.1, 1.3, 1.5, 1.9, 2.0, and please make sure you have that 0.0, don't just put 2, 2.4, 3.5, 4.0, and 4.3. Stem and leaf plots, reading and analyzing. Stem and leaf plot interpretations. Our stem and leaf plot's already created. It's the fish eaten by dolphins. It's in pounds. And if you look at the key, 2 line 0 is 20 pounds. So these are not decimal values. These are whole numbers. How many dolphins ate more than 20 pounds of fish? So we look at our stem and leaf plot and we find the values that are more than 20. 21, 25, 30, 30, 30, and 33. There were 6 dolphins that ate more than 20 pounds of fish. What's the most common number of pounds of fish eaten by a dolphin? So we look on our chart and see which number is repeated more times than any other number. And the most common number of pounds of fish eaten by a dolphin is 30 pounds of fish. Here's another stem and leaf plot. It's practice times. Look at your key. 3 line 6 means 36 minutes because we need to be able to read the information in our stem and leaf plot. How many practice times were under 40 minutes? So we need to count all the values below 40. So all the 10s, 20s, and 30s. There were 9 practice times that were less than 40 minutes. What is the middle or median practice time? We could list all the values in order, like 19, 19, 20, 21, 23, but we really don't need to do that. We can count in from both sides and find the one that's in the middle. The median practice time is 41 minutes. Stem and leaf plots, distribution shapes. We actually saw a few of these distribution shapes for stem and leaf plots on Friday when we were working with the dot plots. The key is to look at the stem and leaf plot sideways. So we are rotating 90 degrees to the left, and then we can show the distribution shape. They have a little kangaroo there because the stems with the fewer amount of leaves are on the right-hand side. That is where the tail is. You don't have to draw a kangaroo. When the tail's going to the right, it is right skewed or positively skewed. On this one, once again, we have our stem and leaf plot. We rotated it to the left so that our line is horizontal at the bottom. And we can see that the tail goes to the left. So this is skewed left or left skewed or negatively skewed. Here's another one. Hopefully you can just look at the stem and leaf plot that's created on the left and see that it's bell-shaped. It is symmetric. But I don't want just symmetric used because there's different types of symmetry. This one is bell-shaped. Once again, you can rotate it 90 degrees to the left and see that, oh wow, there's two kangaroos. And there's two tails, one to the left, one to the right, but our highest point is in the middle. That's bell shape. Stem and leaf plot summary, just a review. We are not turning these or rotating them to the left 90 degrees. We're just going to be looking at them like this. The first one is symmetric, but more specifically, it's bell shape. The highest line is in the middle and it tapers off on both ends. Right skewed. There's more values with the lower numbers, and then the tail goes to the higher numbers, which is right skewed or positively skewed. On the last one, there's more data values in the higher values, and there's fewer, or it tapers off to the lower values. That's where the tail would be, and that is left skewed. Stem and leaf plots, distribution shapes. So we are looking at the one that is created. There's not a key, but for distribution shapes, that's not extremely necessary. We're just looking at the shape of the data. So what is missing? Like I said, is missing a key. Distribution shape, the tail is going towards the higher values, so it is positively skewed or right skewed. Here's another one. This distribution does have a key. Once again, the key is not important. We are looking at the shape of the distribution, and this distribution is bell-shaped, symmetric, but more specifically, bell-shaped. Here's another one. What's missing from the stem and leaf plot? Hopefully you realized it was a key. Not necessary to have a key on this. We are only looking at the distribution shape. There are more values in the higher values, and the tail goes to the lower values because the tallest one, the 90s, is on the far right, or actually the very bottom. This stem and leaf plot is J-shape. Name the distribution shape for each stem and leaf plot. One on the left, bell shape, symmetric. Bell shape is more specific. The one on the right is L-shaped because the tallest row is the one farthest to the top, or with the lower values. If you were to turn that 90 degrees to the left, it would look like an L. Name the distribution shape for this stem and leaf plot. Once again, there's not a key, but it doesn't really matter. There are two peaks, so this distribution shape is bimodal. Here's another one. Name the distribution shape. Once again, there's no key, doesn't matter. We're looking at the distribution of the data values. And each of those rows are about the same length. Each of those rows have about the same number of data values. So this distribution shape is uniform. Here's another one. The tail, once again, is going towards the lower values, but the longest row is not the very bottom. So it is not J-shaped. It is negatively skewed, left skewed, or skewed to the left. There's a few different ways that you can say that. Here's another one. This is symmetric, but more specifically because the longest rows are on the very top and very bottom, this distribution is U-shape. Here's the assignment. There's a stem and leaf plot assignment. It's in Google Sheets. It's posted in Google Classroom. There will be a place for you to submit it. It's a 10-point minor grade. All the problems are there for you. It's all specifically set up and structured to type in the values to make stem and leaf plots. There's boxes to put in your answers to different problems. So you should be great.